Okay, so first of all, I wanted to mention that this is my first time doing any public speaking. So if I'm nervous or making mistakes, please be patient. Or today I'm gonna give you a quick and brief introduction into modern infrastructure monitoring and alerting using open source tools. And yeah, who am I? So my name is Istvan Gyori. I work as a cloud or DevOps engineer at a Danish fintech company, and I have a Linux sysadmin background. My work stack is AWS, Kubernetes, infrastructure as code, Terraform, Prometheus, Grafana, GitLab, Docker, and Ansible. And I've been working remotely since 2012, and I'm based in Budapest, Hungary. You might ask, infrastructure monitoring. So why? If you're a developer, you probably don't care or didn't care until now about infrastructure. But the good news is that all of these tools that I will show today, they can be used, and actually they're very good to monitor your applications as well and troubleshoot performance issues, for example. So what is OSS? Open source tools are licensed so that you can use, study, change the source code, and also distribute the software and the source code to anyone and for any purpose. And next thing is, you might ask, why do you want to monitor things at all? Well, you only need to monitor and measure what is important. So what's not measured and monitored, you can consider that it's not important for your business or otherwise. There are two terms that are quite important in case of contracts and monitoring. The first one is SLA, the service level agreement. Easily put, that basically in the contract you define what kind of services are provided by a service provider, and when can we say that the quality of the service is good enough. And the second important term is the SLO, service level objective, and it's a key part of the SLA of the agreement. And this contains more specific things like you agree that the application will be available 99% of the time or more. And basically, we need the metrics to measure if the SLOs are met. So without measuring and monitoring, you cannot tell that the quality of the service is bad. And luckily, we have open source software tools that we can use. From a bird's eye overview, first we need to expose the metrics that can be collected using, for example, a tool called Node Exporter, or we can expose a metrics HTTP endpoint in the applications that we want to monitor. Applications in this case can be Java applications, Node.js, or even a bash script if you create an HTTP server in it and create this endpoint. Second step is you need to collect and store these metrics. A great tool for this is called Prometheus, and it has a component called Manos that's for long-term storage. After these metrics are collected and stored, you want to visualize them. We use Grafana for this. And as a final step, if things go bad, then we would like to send alerts to developers, DevOps, Ops, or your manager to to basically pick up the phone and start working and try fixing the things. So talking about the first component, exposing the metrics. Basically, we can use Node Exporter for this, and Node Exporter is basically a daemon, and it can monitor your physical or virtual machines. And as a second way, you can use a custom application metrics endpoints in case of monitoring the different services that you might want to monitor. This is for Java, Node.js, and other applications. About Prometheus, it basically collects and stores these metrics. There's a special term called scraping. Prometheus is basically scraping this HTTP endpoint of the applications or Node Exporter. It does this scraping every couple of seconds or every couple of minutes, depends on how we configure it. Prometheus is a free software application, and it has different components. Also, it records the metrics in real time in the time series database. This allows the metrics to be very high dimensionality and high density. It has a built-in HTTP pool model. We can create custom queries and real-time alerts using different rules in it. It's very scalable and easy to configure for high availability. So that means that basically it scales as high as needed. I've seen Prometheus instances running with more than 90 gigabytes of memory, so it's really scalable. And also you can store the entire configuration of the Prometheus instances in a YAML format in Git, so you can version control it. And you store the metrics, or Prometheus stores the metrics in an AWS EBS volume or a local disk wherever it is installed. I've added a link to some interesting Prometheus alerts. You might be able to check it after the meetup. And also I added a URL to this tool. That's important because there are a number of tools with a similar name, so that's the correct URL. There might be or there is an interesting question. Why do you want to pull the metrics instead of pushing them? Well, it's actually one topic that I've seen during my day-to-day tasks. Basically, if you push the metrics to a metrics database or service, you can have many false positive application down called the boss alerts in case there's a network issue between your application or the and the metrics database and service. It's very difficult to create a high available and redundant setup without duplicating the metrics data. Also, you might lose metrics data when you do maintenance on this metrics database or service. And application developers need to take care about sending the metrics. You can have or you can use third-party libraries, but sometimes you need to cache the metrics and make sure that the metrics are really sent and received. This can increase the application complexity. Whereas in the pooling method that Prometheus is using, application developers only need to expose this metrics endpoint, and they can add custom data to it. And developers don't need to worry about anything else, basically. The rest is taken care of by Prometheus. Also, you can be sure that, or this gives you an additional point to make sure that the application is actually working. Even if you do maintenance and upgrades on Prometheus, if, for example, one of the Prometheus cluster nodes are down because of maintenance, then the scraping doesn't stop, like with the not highly available pulling method or pushing method. And it's quite easy to create a highly available solution without duplicating the metrics data, and very easy to do rolling updates on the monitoring cluster itself. Next tool, it's called Grafana. It's for visualizing the metrics, and it's a multi-platform open source analytics and interactive visualization web application. It comes with a powerful WYSIWYG editor. So basically you can see the different charts, graphs, and other components in a web application, and you can edit them there directly. There is no need to manipulate the JSON code for the dashboards. If you want, you can also do that, but this editor is working very well. Also, Grafana supports different data sources like Prometheus, AWS CloudWatch, and other tools. You can usually how we work with this Grafana is we use the WYSIWYG editor. Then after we are done with creating the dashboards, we export them, store them, and how we store it is this can be exported as a JSON, and we can track it in and store it in Git. So we also have version control for this. And Grafana has a built-in protection for this, so that if a dashboard was provisioned from JSON and using Git, then you cannot edit it directly in the WYSIWYG editor, unless you really want to do that. And I also added a link of some pre-built, also open source dashboards. I checked it yesterday. There were more than 4,700 dashboards. So really, almost for everything, there's a dashboard. And I also added the website for Grafana. Next component is Alert Manager. It's basically used to send alerts. Prometheus is so it you can basically create Prometheus rules, and Alert Manager takes care of deduplicating, grouping, and routing alerts to different tools like Slack, PagerDuty, Opsgenie, or whatever else you configure. And also the configuration is stored as YAML in Git. And I also added a link to this. And downtime. Let's see if things break or not. So I already started a stack that is running locally in using Docker Compose. Here you can see not the latest version, but it's a pretty recent version of Prometheus. And basically here you can see the different panels. You can see the active alerts. There are some alerts firing. The Jenkins is down. That's because I don't have a Jenkins running. Also, we can run live queries, and for example, see the currently created alerting rules. When were they last evaluated? How much time did it take to evaluate them? And also we can see, for example, the detected targets. For example, we can see that node exporter is up. It was last scraped 5 seconds ago, but CAdvisor is down. That's because I'm running in a Docker environment currently. Yeah, and next thing is Grafana. Basically, if you open Grafana, it gives you lots of interesting links to look at. I've already created some dashboards. For example, there is this one called Docker host. With this, I can see basically what's happening on my computer. I'm running on Mac and using Docker desktop. So this is why these numbers are presented. So swap and so on. And also we can check the metrics, for example, for the last 15 minutes or 1 hour, we can, using this, we can also check what happened at 2 p.m. today by looking or zooming into a specific place in time. And also we can see, for example, in this dashboard, the IO usage, network usage, and lots of other things. Yeah, we don't want to save that. Oh, and one more thing, this Grafana also supports automatic refreshing of the dashboard. Currently, the metrics are collected every 5 seconds, and basically we can configure it to 5 seconds. Latest version of Grafana and Prometheus, they also support, I think, real-time monitoring. So you can basically see the CPU usage even more frequently. So you don't even need to wait for 5 seconds. And this third tool, Alert Manager, it's basically showing you that, or showing us that currently we have 2 active alerts. One of them is this CAdvisor. There are no permissions to monitor the Docker containers or my machines. So this is why also severity critical. We can create different rules with different severities. And the second alert we can see is that Jenkins is down, and also it's a critical alert. We can also create silences for the different alerts. Let's say we want to silence the Jenkins down alert. Basically, we can tell how long do we want to silence it, why. Let's say I created it. Why? And you can also preview the alerts that would be affected by it. If it is looking good, then just create the alert, and for the next 2 hours, we will not be pinged by this alert. This is very useful if you're working on a new service or you do planned maintenance. In that case, you don't want to be pinged by your alerting. Okay, so some interesting projects I've collected you. Like, what can you do with this? So there was a guy who created a Prometheus and a Grafana solution to monitor his smoker, like how he's making or cooking meat. Also, there's a full solution how to monitor your beer fermentation if you are into beer making. This even has it's a separate dashboard, so it's really useful, not just for work stuff, but some people do it for hobby project as well. And yeah, so all this sounds like a hard thing to try. Well, if you have Docker and Docker Compose installed, I actually searched for a tool or basically a demo stack that you can pull, for example, from this link. I edited it a bit so it is kind of safe to try on your local machines, or even you can deploy it to a virtual machine if you would like to give it a test. Also added some details on how to access Prometheus and Grafana. And yeah, this is a disclaimer that this is intended for testing purposes only. So if you like to deploy it to a machine that is accessible from the public internet, change the default passwords, and make sure that you have a properly configured firewall or AWS security groups if you run it on AWS. So these previous things that I showed in the demo, if you pull this repo, you can try it. So next steps, yeah, I would advise you or suggest you to go to this link and check out these more than 4,000 pre-created Grafana dashboards. It's pretty interesting what different people put together. So you don't need to start from scratch if you want to give this a go. Also, if you have time, pull this Prometheus Grafana demo stack that I prepared, mainly forked, but yeah, also added some steps on how to start this, and convince your fellow developers, DevOps engineers, and managers to start using these tools, because yeah, open source is nice and we should use it. Another next step is would be to check out the monitoring section of the Google Site Reliability Engineering Workbook. I added a link to this one. If you read it online, it is for free. So Google allows everyone to use it for free. And if you want to connect with me, because you have DevOps related questions or questions about this presentation, you can find me on DevStaff Slack. My profile name is IG. I added a link to my LinkedIn. I don't want to read that. And you can also connect with me on GitHub. I'm not too active there, at least not yet. And I had also added my email address. And thank you for your attention. And yeah, if you have any questions or comments, yeah, please shoot me.
Thank you, Istvan. That was great stuff.
Thanks.
So if anyone has something to ask, he can open his camera, his microphone, or he can even write in the chat.
I have one question. Just for the record, this presentation will be uploaded in our GitHub, so you will have everything that it was presented and all the links. And thank you very, very much for this awesome presentation, Istvan. Yeah, let's go to the questions.
I have one question.
Sure.
Yeah.
Okay. I would like to thank you for your presentation. It was very nice. I would like to ask, why did you choose Thanos? Did you validate any other like M3DB or Cortex or Victoria Metrics?
Actually, I wasn't choosing it. So one of my colleagues evaluated the different tools. We really like to use it because it's very tightly integrated with the Prometheus stack. So we use ham charts to manage this at work. And basically, Thanos is the built-in long-term storage in that. Okay. We use that with an S3 bucket backend, so we store the data there.
As a side note, sorry for interrupting. As a side note, I think that Thanos is tightly coupled with cloud environments solely, and it doesn't. It needs significant effort in order to deploy it on on-prem environments at least. So for on-prem environments, maybe you could use M3DB, Victoria Metrics, anything that can support remote write and remote capabilities.
Okay, thank you very much.
Anyone else?
I can ask one question. Can you hear me?
Yeah, sure. Go ahead.
Great. When you, I don't know if you can compare New Relic and Grafana. Can you just tell me how Grafana is better than New Relic? Because in my previous company, we were using New Relic and it was consuming too much RAM and CPU stuff, and Grafana was not like that, or I don't know the details.
So New Relic is, as far as I know, it's similar to, for example, InfluxDB. So it's a push-based thing, not pull-based. So you need to connect to New Relic APIs and push there whatever metrics you have. The first thing that comes into my mind is the pricing. So with New Relic, it's costs a lot of money after you reach some point with the amount of metrics. Whereas if you manage your own solution using these open source stuff, that's obviously much cheaper. Regarding the performance, Grafana is just visualizing the things that Thanos is, or that is stored in Prometheus. So depends on how bad or good your Prometheus queries are. That's also meaning like, so if you create bad queries that is querying lots of unique entry point data points, then Grafana is slow. Otherwise, if you have good queries, then it will be very fast. So if you use these latest versions, you can, as I briefly mentioned, you can even create a real-time metric tracking. So track the CPU usage, for example, in real time in Grafana. So it's very powerful. I don't have these kind of experiences with New Relic. So
thank you very much.
Sure.
Thanks.
Okay, there are two more questions from Yorgos in the chat, which say, what are some limitations you have found in Prometheus, and what would be something that you wouldn't choose Prometheus to monitor?
Okay, so Prometheus limits. Well, if one thing is the cardinality of the metrics. So basically, that means that Prometheus works as also any other time series database. It works very well if you have less unique metric points and lots of metrics for that. For example, if you measure the temperature of the room, then that's one metric to measure the temperature, and you can have lots of data to that. In that case, Prometheus is very fast and very memory efficient. But if you would like to measure the room temperature like that, you have different, let's call these buckets for every temperature grade. So like you collect metric for temperatures between 1 and 0, or 0 and 1, then you have a separate bucket or metric point for temperatures between 1 and 2, and so on. Then it can consume lots of memory, and it can be very slow. Or another thing is if you monitor the HTTP web server response times. So also Prometheus has a very powerful query language, and it can calculate you the percentages of like how much of the responses were faster than 10 milliseconds. If you allow Prometheus to calculate it, it's very fast. But if you collect lots of different metric points or these buckets for the different response times, then it will become very, very slow and memory consuming. And to answer the other question, what wouldn't I use it to monitor things? That's a good question. Actually, at the place that I'm working for, we use this for everything. I mean, we use it to monitor our Kubernetes clusters, monitor the virtual machines that Kubernetes is running on. We use it to monitor the application performance. One thing that we don't monitor directly is, for example, so as I mentioned, we work in an AWS environment, and we don't monitor the managed services that closely. So for example, RDS metrics are not wired in that deeply into Prometheus. And also you need to be careful, or yeah, you can say careful about what you want to monitor, because if you you can have problems if you want to monitor too many things. So you need to be careful to monitor only the things that that are actually interesting. So let's say your machine can have metrics for thousands of different things, but you only care about free memory, free disk, and CPU usage, and things related to that. So it might be enough to just collect metrics for those. So you don't want to overload your metric system with stuff like megabytes per second of internet connection speed of your laptop, or things like that. So
okay, great. There are two more questions in the chat, and Istvan has raised his hand. Yes. But we are running a little bit behind our schedule, so let's. I propose, if that's okay, to jump to our next presentation by Manos, and then we, at the end of the meetup, we can discuss every question. So Sven, if you can just write your question to the chat, and we will recap them at the end. Just okay, not delay Manos. Thanks a lot once again, Istvan, and the stage is yours, man.
Okay, hi guys. Thank you, Istvan. It was a very nice presentation, and it's a proven stack that you presented. Now, hi guys. My name is Manos. I'm from Crete. Used to be a software developer and then worked in Vodafone Group in Germany in let's say big scale international projects. Now working on the product team of Netdata. I will present you about Netdata as a monitoring and troubleshooting tool, and it's not for sales. I think it's a good tool. It's free, and I hope you enjoy it. Okay, now let me share my screen for a little presentation. So everybody has a plan. We are all in the IT industry. We have want to offer value to users. We create product teams, project teams, deliver stuff, deploy stuff. And yes, everybody has a plan, but everybody has a plan until they get punched in the mouth. And this is something Mike Tyson said, and I think it's very true, especially on the IT world. We can be all very well prepared, but almost everything can go bad. And when you are in production, you don't have the time to really go to your monitoring tool to set up everything. The clock is ticking. You cannot really jump on the console and try to understand what went wrong. And in regards to monitoring, you can have either open source tools on your tool sets that most of the times they need a lot of configuration. So either you pay with time, or you can sell a small piece of land to have the enterprise grade tools like Datadog or Instana to to have enterprise-grade monitoring with the possibility to be in a better position when things go bad. And regarding NetData is an IT infrastructure monitoring and troubleshooting tool. We monitor and alert systems, package, and custom applications. Can act as a standalone tool, but also as part of an observability stack. And primarily, it's created to address the needs of SRE, DevOps, admins, everybody who wants to see the health and performance of their systems, but also to, as an extension, we are addressing to software developers. And NetData has, let's say, two components. Both components are free. The NetData agent is open source, is a monitoring agent that you can install on your host, and it collects, categorizes, stores thousands real-time metrics. Then it's created in a way that it presents these metrics in charts in an automatic way on ready-made dashboards. It has services that are auto-detected, so essentially you don't need to do anything, and has out-of-the-box alerting. So we can offer more than 300 stock alerts that run after installation, and also it can notify you through different methods. So you can get emails, you can get SMS through Twilio integrations, notifications, Slack, or other channels. And it has also more abilities. It can export metrics to other time series. For example, we can export through the agent data to Prometheus and then visualize it through Grafana. But also, it can stream data to other NetData agents. We are talking about decentralized monitoring, and this means that sometimes you want your monitoring data to be located to more than one machine. For example, when you have a node that goes down, it's good to have the monitoring data of this node to another machine so you can do post-mortem. And the NetData agent can, with minimal configuration, can stream to other NetData agents, and actually you don't need to configure other tools or Thanos. It just works. And another good thing about the agent is that it plays well on the system. So it has near zero overhead. It's very snappy. The data are stored in a memory database. And I would say this is it. It's an open source tool. It's free, and we have a vibrant community where you can be part of it and contribute on the code base. Then the other component is, give me a moment, please. The other component is the NetData Cloud. The NetData Cloud is a software as a service offering. It's free and it will remain free. And it's used for infrastructure level monitoring. So you can have monitoring of all your nodes in your infrastructure. It's infrastructure with organized in space and volumes. So you can have all your infrastructure in the space and all the bigger organization on the space, and then slice and dice infrastructure and teams to war rooms the way you see fit, and then monitor and troubleshoot the specific war rooms. I will showcase this in some minutes. Then it has the ability to show individual charts from all nodes on this entity we call war room. You can create very easily custom dashboard. You can see all your active alerts and even centrally have dispatch of notifications and alerts if your node goes down. It has some other items like Kubernetes monitoring and some intelligent features that, like metric correlations, that can help for root cause analysis. And NetData as a whole, as a proposition, it has some competencies, so it's fast and easy. Anyone can do it, and I can show you in some minutes. It provides instant insights, so even if you are not experienced, if you are new to monitoring, you can run a single command and then have an out-of-the-box dashboard with already organizing charts with explanations, and you can start monitoring, or you can start learn monitoring with metadata. It doesn't need a development life cycle, actually, and this is a big thing because most of the DevOps SRE teams spend days and weeks and months to set up their and operate their stack. With metadata, this is not the goal. The goal is we want our users to focus on providing business value, not managing their monitoring. We have really unlimited high resolution data. So even on a normal VM, if you run the data, it collects more than 2,000 metrics, and most of them are on a per second granularity. As I said, for us, it's pretty important that you have near zero overhead. So your if you install the data, it doesn't harm your system. And it's important that we are also an opinionated monitoring and learning tool. So with metadata, you get some same defaults. And I would say that's it with the presentation part. And I think it's about time to go to the little demo. Give me a moment, please. For example, here is how metadata looks like after you install it. You run a single command on your terminal after you SSH, and then metadata runs automatically on the port 19,999, and you see a ready-made dashboard. On this ready-made dashboard, you can navigate to different sections. And for example, this is a VM that has only a single application, a web server, and a squid. But already metadata is able to find many different metrics and organize them in charts. So you can really see a lot of performance, a lot of your performance of your applications. You can see a lot also about many parts of the system, the networking stack. For example, you can see the TCP connections. You can see things around the IP networks you have, the network interfaces, the applications. It's very important that we have all the data you need and more. And we also have explanations. So we try to educate users on what each metric is. For most of the monitoring systems, the things the value you can get from the monitoring depends a lot on your experience and your ability to create your dashboards, create charts, query metrics, add them to charts. And especially if you are not very experienced, you might be blind. And that's why I suggest to our users to use such a tool that can give you a lot of value instantly after some seconds of installation. On the tool itself, you can see also the alerts that are raised. For example, this agent doesn't have any raised alerts, and you can see all the alerts that are out of the box configured. Information about the configuration, how often they run, and what are the thresholds. You can see if the agent is updated, see some news about the product, and also important export and snapshot. What is this? Sometimes, if you have, let's say, an incident, or you are interested to monitor for a specific time frame, due to the data retention of the agent, you don't want to lose this data. And the agent gives you the ability to store it locally and then upload it and troubleshoot on this time frame again. Metadata is used also to help international teams troubleshoot, so you can change the time zone and see metrics on the different time zones you choose. You can see live charts interacting, or you can define your quick time range or your custom time range. And also a very important thing for the agent is that we try to use the powers of EPPF. EPPF is a new technology. It's here with us, I would say, the last 5 years, and it gives the ability to query the kernel some questions and get answers. So there are some open source tools from Cloudflare and IOVisor that are giving the ability to have highly differentiated metrics based on EPPF, based on answers that the kernel does. And what we do at Netdata is we try to provide you out of the box all this knowledge. So instead of having to get these tools, compile them, put them on cron jobs, run them, get the data, store them in a database, then go to create a dashboard, a chart, have a query language, and do it again and again and again, and spend really a lot of amount of time. Out of the box, you can have charts that are highly differentiated, that they are exposing the secrets of the kernel, like this one, like your virtual file systems, and more. And another ability the agent has, I mentioned before, is to send alerts to notification systems. But I'll demonstrate it mostly from the cloud. And I would say this is for now the agent part, just to see how important it is to be real time and to see what changes are happening in real time. I will do a very little change. Please give me a moment. You see this. You see this machine is an idle machine. I will go to the terminal of another machine, and I will run an attack on the web server. And the nice thing is that immediately, real time, you see what's happening and what's the impact. Regarding let's say the streaming capabilities of the agent, it can stream data to another. So, for example, now this machine is streaming data to this one, and you can actually, by accessing the parent, have access to both machines. Now, in terms of the cloud is a solution that is, as I told you, closed source. So you can't really contribute on the source code, but it's free and it will remain free. It's designed to help you monitor and troubleshoot infrastructures. So not a single node, but services actually. And as a new user, after a sign up, the only thing that you need to do is to actually connect nodes to the space. Here is what you see usually as an empty space, and you can connect the nodes. It's a single command. You get a coffee, the node is there. You can have Linux, you can have macOS, you can have Docker containers with different installation methods. You can have a Kubernetes cluster with Helm installed. And now I've shown you from a very little infrastructure to machines. After installing them and connecting them to cloud, you get to a war room, and on this war room you can see now the overview. In the overview you can see all the charts you saw on a single machine, but now with the metrics combined into a single chart. So in this case, you see the average of the CPU utilization from these two nodes. You see this little spike that was created after running the attack, the stress. And you can see that even on cloud, give me a moment. Even on cloud, if the charts are playing, the attack and the data are coming instantly through a secure bidirectional connection the agents have with the cloud. It's based on secure WebSockets. Important thing for the cloud is that we take care of privacy and security for you, and the data, the monitoring data you have, remain on your infrastructure, remain on the host system, and they are just streamed to the cloud to be shown to your browser. For some charts, we do some calculation, but no monitoring data are stored on the cloud, only metadata, because data privacy is important. We have slightly different charts on the cloud. Is the next generation of the charts, and you can do some actions. You can pan the chart, you can highlight the chart, and you see this highlight across, let's say, across all charts. You can select and zoom, either zoom to a specific. You can either zoom to a specific time frame, or if you are interested to zoom vertically, you can see some spikes, for example, and focus on the chart. Also, you can zoom out again and see a different time frame, or reset the zoom factor. The metadata charts that you see here provide the explanation again, but also additional information on how the data have been collected. There are some options to change the visualization type. For example, here you have a stack chart, but you can switch it to line chart. You can see the charts full screen, minimize, or add the charts to custom dashboards. And now let me show you a little bit of the custom dashboard feature. You can create custom dashboards. And why this is important, because you can combine metrics from a single node, or these composite charts that show metrics in a combined way from all your nodes. So now I created a dashboard for CPU and Apache logs. I added some data from all the nodes. You can easily change the position of the dashboard. You can add new charts, for example, from the parent node, and just collect the context, just collect what you want to see, instead of pulling all the resources together. So, for example, here we will see the memory of the applications if we like, and with a click of a button, we will add it and save the dashboard. Another important feature of the dashboards that you can use is the ability to pin a dashboard. So if you want to do comparison, you can. Sorry, this didn't work now. Okay. Another screen we have is the Nodes tab. On the Nodes tab, you can see an index of all your nodes, and you can you can see some key metrics, and you can see if the nodes have alerts. And by clicking on the node, you can have a new tab and then navigate to the metrics of a single node. This is very similar to the navigation you have on the agent. We have an intelligence feature. So, for example, if you see a spike that is worth investigation, you can run the metric correlation button, select an area of interest, for example, the spike, and then give me a moment, and then you can try to see which other metrics out of the 1,000 metrics we provide have similar usage pattern. And in the data, it's important that we have so many metrics. It's important that the metrics are really with high granularity, but most important is that you can correlate this spike to other metrics that have similar usage pattern. And let me now do it again for a moment. Sorry, I'll go again to this little node because I lost track of it. We'll wait again some seconds because I forgot to show something. The data, yeah. So you see which other metrics on the systems have a similar usage pattern, and you can really go down to find the root cause. Another feature that there is on the cloud is the alerts. This space doesn't have alerts. Let's go to one that has. And we have the alerts tab where you can see all the alerts, out of the stock alerts that are offered. And then you can filter the alerts to limit down to the alert you are interested. You can filter based on class, based on the criticality, the node, or other stuff. And after you are focused on an alert, you can see the alert information in a nutshell, both the chart and some information about the configuration of the alert. You can go to chart, you can run the correlations to find the root cause, or you can get some suggestions from the community. Over there, we have an explanation for each alert, what it's about, and members of the community can join and contribute. Another feature we have is the Kubernetes visualization. So if you have a Kubernetes cluster, you can monitor it as part of the resources. And what's happening with the data is that out of the box you have, let's say, your Kubernetes cluster. Here it's colored by the CPU limits. You can see it by container, by pod. And below you have all the charts that are associated with this cluster. And the data is kind of snappy. You can go back in time and see how the different pods of the infrastructure are changing their values now for the average CPU limit. And you can go to a pod of interest or a node of interest and get more data about what it is and a few information about their key metrics. The only thing users need to do actually is to install the data and connect the nodes to the cloud, split them to the war rooms of interest, and then go and monitor. And again, on the cloud part, it's important that data remain on your host. They are just streamed, they are not stored. And I would say this is it. And happy to answer any questions you may have.
Thank you very much, Manos, for this nice presentation. Claps from everyone, I assume. And yeah, let's jump directly to Q&A for your presentation and then for general purpose as well. I think that some can be for both of you. An answer can be given for both products, let's say, that were described. So one question from Ioannis was if, let me find it, sorry. Yeah, is Prometheus or NetData compatible to open telemetry standards? So servers do not need to provide metrics in a custom format?
Yes, Prometheus is closer to the standards. Yes, and I would say that the OpenTelemetry standards are kind of tailored to what Prometheus provides. But we have another approach. We don't have actually storage of metrics. We organize them and group them to charts, and but soon we will engage to see how we can let's say be better aligned with the open metrics and open telemetry standards.
Okay, I assume that the answer is given from Prometheus. Istvan, do you want to add anything?
On this, we support the Prometheus format, which is let's say the most popular out there. And we have also a custom Prometheus collector. So if your application exposes metrics on Prometheus format, it's very easy to configure the endpoint, configure the job, and then you see the charts on a data as well.
I actually found a Prometheus exporter for this OpenTelemetry, so it seems that they are not compatible. I didn't mention, but also Prometheus is supporting lots of third-party so-called exporters that can present data in a way that Prometheus can scrape it and collect it and store it. So out of the box, no, they are not compatible, but they can be made compatible. There is a tool for that.
Okay. I think that there was a question that can be answered. So how about application logs? Could we use these tools to aggregate and query logs from various data sources? If so, which are the proper storage solution for app logs generated from a logging utility? I think that it is.
I think it appeared with the Prometheus stuff. So quick answer, no, Prometheus is not suitable for this. But also developers of Grafana saw this. So they created a tool called Grafana Loki with a K. And that's exactly for this. So that's, as far as I know, it's also an open source tool. You can deploy it into your infrastructure. And that's exactly for this purpose, to ingest and collect lots of logs and make it easily searchable for you.
Great. If we can just share it in the chat, this one would be nice for publishers to be aware of that.
Yeah.
And
NetData, we don't have log support. And if you want to have, let's say, a modern observability stack, at the moment we suggest that you use other tools for logs and tracing. There is intention to not to go to the tracing at the moment, but logs is something that we would like to offer. But I don't have something tangible to say on this. For now, it's better if you use other tools, and Loki is a very good example.
Okay, good. And the next question is from Sven, I think. Yeah. What is your feeling about using Prometheus for monitoring network infrastructure? I'm looking for a network about 1,000 locations with about 10 to 20 devices in each location, where I could like to get alerts if the network infrastructure is having a problem somewhere, and or if a certain device has become not available.
So,
sorry for that, Manos. I think this is Istvan related specific.
we can also answer that. Sure. Just go ahead, Manos.
Yeah, NetData provides SNMP monitoring, but you can also monitor your network devices by other ways. And yeah, you can use this parent and stream, let's say, data from your network devices to the parent and monitor them. And after you connect the parent on the cloud, you have also let's say these offline alerts, which alert you if the network device is down.
Nice.
And in case of Prometheus, it's not really suitable for this because Prometheus needs to have access to these devices. So if you have,
yes, I figured.
Yeah. So, but if you can create some metrics endpoint, maybe in these locations, if you have, I don't know, VPN servers or endpoints, or actually, if you would have a VPN server that has metrics endpoints, then Prometheus could scrape data from there.
For this amount of, because you said if you have a lot of small buckets,
yeah,
it would be a problem for Prometheus. So I would assume that this probably would apply for that problem, or.
The good thing is that it depends on really what kind of metrics do you collect, because if you so for the metric endpoints, you can also assign labels. These labels can be like a machine name or device name and similar things, and those are not calculated as unique metric endpoints. So in this case, it would be good for that, so that it wouldn't be a problem. Because if you would monitor maybe just if the host is up or down, then just a single bucket that's up or down.
Because I see on the Grafana dashboards that there are several routers there that they are seeming.
Yeah. So it could be used. And also the good thing here is that Grafana, in my demo, I shown how it works with Prometheus, but it works with a lot of other data sources as well. So you can connect it to AWS or maybe specific router manufacturers. I haven't checked, maybe it's working with MikroTik, for example, and other vendors as well. So it can even display data from you from a text file, if that's properly formatted. So it's very robust. Sure.
I assume the question about SNMP monitoring is already replied. So the next question for NetData is what is the storage engine of NetData? Is it a custom one? Does it depend on existing TSDB like RRT?
We have a custom database in memory. That's why we have very snappy, let's say, charts. You have data collection to visualization latency in of some milliseconds, and now we are trying to see if SQLite could be an option. Regarding the RRD database, it's not a database with tiering capabilities like the RRD so far. So what tiering means for the audience, there are some databases that if you go back in time, they assume that you don't need to have very high granularity on your data. So they, let's say, average data through time. So the data for a day can be very high, with very high granularity. The data from the first day to the first week could have lower, etc., etc. Because many people have the need to monitor the infrastructure, and especially for capacity planning, to see how infrastructure performs over time. But net data overall is a tool that is primarily to be used for troubleshooting, and for troubleshooting, let's say, so far this longer retention wasn't a key need.
And so one more data related question is about what's the difference between internal and external collectors? How do external connectors work?
There are collectors that monitor resources that are outside. An example of this is our WMI collector for Windows, and usually we connect to an endpoint and pull data in, and we monitor. While the other collectors, they run locally on the host systems and store locally the data. If I hope I answered the right question.
Okay, I would suggest to stop the recording at this moment, and we can freely stay here and have a more relaxed conversation and questions, and grab a beer, whoever wants. So officially, once again, thanks both of you for these great presentations and for the time that you invested for making all this stuff and presenting them to DevStaff Meetup.